In the first model of lesson 2, the first question of lesson 2, or the first part of lesson 2, we have this problem. The Dude's Cookies is a company. It makes large cookies with crazy stuff baked inside of them, like nuts, chocolate chips, banana chips, peanut butter chips, dried fruits, etc. The probability distribution for the number of cookies that it can sell on a given day at a local gas station is given in the first two columns of the table. So this right here is the number of cookies sold, and that's the probability. This is the number of cookies sold, and that's the number of probability of one cookie being sold. And then two cookies being sold has a probability of 0.2685. Three cookies being sold, we got to calculate that. Four cookies being sold is that probability. And then the probability of selling 5 or more is 0. So what we want to do is we want to copy this table along with a letter outside the table to Excel. Now I got to fix the formatting here, right? So this is x minus mu. I'm going to change that font to symbol. When you type symbol for the font, you get the Greek letters. And then I'm going to drag this over here. And I'm going to change this to x minus mu and then a 2. I'm going to format this so that it's uppercase, superscript. And then I'll drag it over here. And I'll change that to 2. Whoops. There we go. And then this is going to be f times x. F of x, sorry, f of x. This right here is the probability of x equals 0, 1, 2, 3, 4, or greater than or equal to 5, right? And this is a square deviation from the mean, right, which we compute in column E. Now, this is actually greater than or equal to 5, so I'm going to underline that. So we got greater than or equal to 5. Okay, and then I'm going to set the decimal places at 4 for all of these. Okay, so the first thing we have to do is we have to calculate this probability, right? These have to sum to 1, right? So to calculate this probability, we have to do equal 1 minus the sum of what? Well, of these, comma, those two, right? And when we hit enter here, we get a probability of 0.2973, and now all of those probabilities sum to 1. So yeah, they sum to 1 here, right? Okay, so we can double check to make sure we got it right by doing this, by plugging that in there. Okay, now we want to find the expected value, right? We want to find the expected value of this distribution. The expected value of this distribution, if this were a uniform distribution, these probabilities would be equal. Each of these probabilities would be equal to 0.2, 1 divided by 5. Well, because the probability of x being greater or equal to 5 is 0, right? We really have just 5 outcomes. X equals 0, 1, 2, 3, 4. And 1 divided by 5 is 0.2. So all these would be 0.2, right? And if that were the case, then we could just average these and we would get 2, right? Which makes sense because 2 is the middle number, right? And if these are all the same, 0.2, then the middle number would be the average, right? 4 plus 3 plus 2 plus 1 plus 0, that averages to 2, right? But that's not the case here. We don't have equal probability. So what we have to do here is we have to multiply the value of x times its probability first, right? So 1 times its probability, 2 times its probability, 3 times its probability, 4 times its probability. And then we have a problem here. This is a string of characters. It's a word, essentially, to Excel, right? It's no different than a word to Excel. We can't multiply a word by a 0, right? But what we can recognize is that 0 times anything is 0. So we're just going to type that as 0. Now, I'm going to change this to 4 decimal places. Change these to 4 decimal places. And then I'm going to sum to get the expected value. So the expected value is 1.8375. Now, these 3 columns are going to be used to calculate the variance, which is going to be the sum of the final column, right? So we're going to calculate the variance of this distribution, we first have to calculate the deviations from the mean. And the deviation from the mean, where x is equal to 0, so we got x equals 0 minus the mean, and the mean is the expected value here, right? And I'm going to drag this down to calculate the other deviations from the mean. When I do that, this red box will move down 2. So what I want to do is I want to freeze the red box in row 8. And I put a $sign between the column letter, and the row number, which is 8, right? And that'll freeze the row number at 8 to keep the red box at the expected value. And all I have to do now is just drag this down. Okay. Now, here we have a problem. We are taking this string of characters and we're subtracting off a number, right? So what we're going to do here instead is we're going to change this to 5, right? 5. I'm going to type 5 there because the number here is 5, right? So that allows us to calculate a number there, right? Now what I want to do is I want to square these deviations. So I'm going to type equal D2 for this first deviation from the mean. I'm going to raise it to the second power. I'm going to change this to 4 decimal places. And then drag it down. Okay. Now, the last thing I need to do is I need to multiply the square deviation from the mean by the probability, which is 0.1639. And then I need to do it for all of these, right? Okay. So the sum of this final column is the variance. Then I'll set these at 4 decimal places too, right? So let's just see if we got these correct. So the first product of x times its probability is 0.000, right? The deviation from the mean, 0 minus 1.8375, is a negative 1.8375. All that means is 0 is below the mean, and it's below the mean by the amount of the mean, right? Now the square deviation from the mean is 3.3764. When I multiply that by the probability, I get 0.5534. Okay, now when I multiply x equal 1 times its probability, I get 0.2242. And 1 is below the mean, and it's below the mean by 0.8375. The negative means it's below the mean, right? And then I square that, and I get 0.7014. Notice the square deviation from the mean has declined, right? The closer we get to the mean, the smaller these two numbers get, right? 0 is a lot further from the mean than it is 1, which is why its deviation from the mean and its square deviation from the mean are larger than that of x equal 1, right? Then I got to multiply that by the probability. So I multiply this by that, and I get 0.1573 right here, right? Let's just check to see if we got those 8 things correct. And we did. Okay, now we're going to multiply 2 times its probability. And 2 times its probability is 0.5370. Notice that the deviation from the mean is positive. That's because 2 is greater than the mean by not much, right? It's greater than the mean by that amount, right? Now, when I square that, I get an even smaller number, right? When you squared numbers between 0 and 1, the result gets even smaller, right? And then I multiply that by its probability, and I get an even smaller number, right? We'll check to see if we got them right, and we did. Okay, now we want to multiply 3 times its probability, right? 3 times its probability is 0.8919. And then we're going to take the deviation of the mean. 3 minus 3 is greater than the mean, right? And it's greater than the mean by this amount. We square that, and then we multiply that square deviation from the mean by the probability, and we get that number. Okay, then we just continue. We're going to multiply 4 times its probability. We're going to subtract 4 from the mean, which is 2.1625. We're going to square that. We get a number greater than 4, which makes sense because 2 squared is 4, right? Then we multiply that value by its probability, and we get 0.2156. Looks like we got everything correct now, right? Now, this is 0 because 0 times anything is 0. And the deviation of 5 from its mean is 3.1625. The square deviation is 10.0014. And 0 times anything, the probability is 0. 0 times that is 0, right? Okay, so the expected value is that number, the sum of these values, and the variance is the sum of the final column. Okay, so this is the variance, and this is the expected value. We'll call it E of X, and we'll call this the variance of X. Okay, the standard deviation of X is the square root, right? Okay, what is the probability of selling 3 cookies on a given day? Well, we calculated that right here, right? Then we're going to answer the questions. Find the expected number of mini cookies sold in a day using the discrete probability distribution. Well, that's the expected value, right? We expect to sell 1.8375 cookies. Find the standard deviation of the number of crazy large cookies sold in a day using the discrete probability distribution. Well, the standard deviation is the square root of the variance, right? That number. Okay, something that we do in statistics a lot is we calculate the thing called the within 1 standard deviation of the mean interval, the within 2 standard deviations of the mean interval, and the within 3 standard deviations of the mean interval. Okay, so what we want to do here is I'm going to copy this here. I'm going to copy it here, and I'm going to copy it here. I'm going to change this to 2. I'm going to change this to 3. I'm going to add a plural to standard deviation. I'm going to make standard deviation plural. Okay, so then I'm going to pull these over to here. Okay, so I got the lower limit and I got the upper limit. Okay, one standard deviation below the mean. I got the mean, which is 1.8375. I want to be below it, so I'm going to do minus. And I want to be one standard deviation below it. So 1 times the standard deviation. And I'll change this to 4 decimal places. All these to 4 decimal places. Okay. Now I'm going to copy this here. I'm going to copy that. And I'm going to paste it right here. I'm just going to change the minus to a plus. So this gives me 1 standard deviation above the mean, right? Then I'll pull these two down. And what I need to do is I need to fix both of these in their respective rows. So putting the dollar sign before the row number freezes this red box in row 9 and freezes this blue box in row 8. And then I can drag them down. Now I'm going to change the 1 to 2. So this is going to be 2 standard deviations below the mean. And this is going to be 2 standard deviations above the mean. And then I want 3 standard deviations below the mean. And then I want 3 standard deviations above the mean, right? And then I just enter these values with the smaller number on the left and the large number on the right, one at a time. I mean, you can think of this as all the observations because probability of 5 or more is 0, right? So this is really a finite discrete probability distribution with just 5 values, right? And the minimum is 0 and the maximum is 4, right? All of those values are within 3 standard deviations of the mean. All of those values are within 2 standard deviations of the mean because really the maximum value is 4 and 4 is less than 4.14 and the lowest value is 0 and 0 is greater than negative 0.4734, right? So all the values of x, all the feasible values of x are 100% of them are within 2 standard deviations of the mean. 100% of them are within 3 standard deviations of the mean. With regard to within 1 standard deviation of the mean, right? Only 1 and 2 are within 1 standard deviation of the mean, right? So the probability of being within 1 standard deviation of the mean is what? This probability is 2 divided by 5, right? And this is 1, and this is 1. So these are the probabilities of being within 1 standard deviation of the mean, 2 standard deviations of the mean, and 3 standard deviations of the mean, right? A normal distribution is about 68%, 95%, and then approximately 100%. And so we can see that this is not close to normal distribution, right? These two are pretty close to what they are for normal distribution. This is way below what it is for normal distribution. Okay. Let's double check to make sure we got these right by hitting enter.